Welcome back. So today we're unpacking a really fascinating technical article straight from the GitHub blog. Now, if you're a developer, there's a very good chance you've felt the friction of GitHub's recent availability issues back in late April. I know, downtime is incredibly frustrating, especially when you're completely in the zone. But what's happening behind the scenes at GitHub right now? It's nothing short of a massive, industry-defining architectural shift. In today's explainer, we're breaking down GitHub's radically transparent report on exactly what broke, why it broke, and how the explosive rise of AI is essentially forcing them to rewrite their playbook completely on the fly.
Okay, let's dive into this. We're going to cover a lot of ground today. We'll start with those unacceptable outages at GitHub, then move into AI and the massive 30x scale problem. We'll look at the anatomy of a pull request, analyze those April incidents, see how they're rewiring for the future, and finally wrap up with transparency and next steps. We'll get this all demystified for you step by step.
Section 1. Unacceptable outages at GitHub. Let's get right into it.
Look, if your workflow ground to a halt recently, your frustration is totally justified. When the platform hosting the world's code goes down, the entire industry feels it, and GitHub absolutely knows this. Their CTO, Vlad Fedorov, put it incredibly bluntly. He said both of those incidents are not acceptable, and we are sorry for the impact they had on you. You know, there's no PR spin here at all. It's just a really humble, honest admission that they fell short. And honestly, that sets a remarkably transparent tone for everything else we're about to uncover here.
Moving to Section 2. AI and the 30x scale. To really understand these outages, we have to look at the hidden force that's straining their entire system. It wasn't just a bad line of code pushed to production. It was an unprecedented, completely unforeseen surge in automated scale. Let's walk through this timeline to see how insanely fast the goalposts moved. Back in October 2025, GitHub was executing a pretty solid plan to increase their capacity by 10x, which, by any standard, is a massive upgrade. But then, right around the second half of December 2025, everything changed. Agentic workflows accelerated sharply. By February 2026, literally just a few months later, GitHub realized their 10x plan just wasn't going to cut it anymore. They figured out they needed to design for a future requiring 30x of today's scale.
30x. I mean, really think about that staggering multiplier for a second. Imagine your own application suddenly needing to handle 30 times its current traffic, and not in a few years, but starting right now. This is the exact core metric forcing GitHub to completely redesign its infrastructure, essentially on the fly.
Now, what's really interesting about this is the driving force behind that massive 30x number. It's what we call agentic development workflows. We aren't just dealing with human developers typing at keyboards anymore. AI agents are literally writing code, creating repositories, opening pull requests, and hitting APIs at incredible machine speeds. AI is fundamentally changing how software is built, and it's generating this insane workload that's growing exponentially across literally every measurable metric.
Section 3. Anatomy of a pull request. Let's look at why this exponential growth hurts so much.
So why does exponential growth hit infrastructure so incredibly hard? Well, it's because in distributed systems, workloads compound. When a human or an AI opens a single pull request, it doesn't just ping one single server. No, it touches Git storage, mergeability checks, branch protection, GitHub Actions, search, notifications, permissions, webhooks, APIs, background jobs, caches, and databases. It's like a massive butterfly effect. Just one click triggers an absolute avalanche of internal requests, especially when we're talking about massive enterprise monorepos.
And here's the kicker. At high scale, small inefficiencies violently compound. This is the hidden danger of coupling in a distributed system. Deep queues start causing timeouts. A totally simple cache miss suddenly turns into an overwhelming database load. Retries just amplify the traffic even more. Because these subsystems are so deeply interconnected, a single slow dependency can cascade and degrade several different product experiences all at the exact same time.
All right, move into Section 4, analyzing the April incidents. Let's get specific. Keeping that big picture of AI scaling and compounding load in mind, let's actually break down the specific downtime you probably experienced back in late April. Comparing these dates reveals two very different incidents. First, on April 23rd, the merge queue system suffered a regression. Basically, if you were using the squash merge method with more than one PR in a group, it produced incorrect merge commits, reverting prior changes. That alone impacted 658 repositories and over 2,000 PRs. Then, fast forward a few days to April 27th, and an entirely different system got hit, Elasticsearch. An overloaded cluster, which they think was likely due to a botnet attack, caused the search UI to just stop returning results. Now, it didn't break core Git, but obviously, a broken search UI causes massive disruption to your user experience.
But hey, here is absolutely the most crucial takeaway from this entire report: zero data loss. Despite all the severe disruptions, the broken search UI, and those process failures that caused incorrect merge states, your core Git data was never at risk during either incident. Every single commit remained securely and safely stored in Git.
Section 5. Rewiring for the future. How are they fixing this?
Knowing the root cause is great, right? But how are their engineering teams essentially rewiring the airplane mid-flight? So the crucial point is this strict new operational hierarchy they've put in place. Step 1, availability. Step 2, capacity. Step 3, new features. GitHub is proving right now that keeping the site online and stable absolutely trumps shipping flashy new tools. They are actively cutting out unnecessary work so they can focus entirely on resilience. And what does that resilience actually look like in practice? Well, it looks like some seriously heavy-lifting architectural migrations. For one, they're moving webhooks entirely out of MySQL to reduce database load. They're also accelerating the migration of performance-sensitive code out of their Ruby monolith and into Go. Plus, they're isolating critical services like Git and GitHub Actions from other workloads. This ensures that if one thing breaks, it doesn't take down the entire core platform with it. Basically, they're deliberately shrinking the blast radius and removing single points of failure, which ultimately charts a path toward a highly flexible, multi-cloud architecture.
Finally, Section 6, Transparency and Next Steps. To wrap up our deep dive today, we really need to look at how GitHub is permanently changing its communication strategies moving forward, because they heard the feedback loud and clear. Developers need to know what's going on. So their updated status page now includes actual hard availability numbers. But even better than that, they're committing to statusing all incidents, large and small. What does that mean for us? Well, it means you'll no longer have to sit there refreshing your terminal, guessing whether a failing push is a problem with your local network, your own code, or GitHub's infrastructure. You're going to know instantly.
The way we build software is changing literally overnight. AI agents are fundamentally rewriting the rules of scale, and even the platform that hosts the world's code had to go right back to the drawing board to keep up. So, I want to leave you with this final provocative thought to take back to your own engineering teams. As agentic AI forces a 30x acceleration in software development, is your own infrastructure ready for the shift? Keep learning, keep building, and we'll see you in the next explainer.